Doesn't show. This meeting is being transcribed.
Yeah, I just got a notification that on my end it says it's recording.
All right, thank you. Yeah, everything is so slow. Finally here too. All right. And I'm starting AI. Okay. All right. I hope no one is waiting in the waiting room. Uh, all right. Okay. Sorry for the confusion. Um, all right. Well, welcome to Math 531. This is the, oh, shoot. I think the picture is not very good, is it? There's a lot of, so this is the book we will be using. It's under your textbook, my textbook, okay? Um, let me see if I can get better light. Okay, so we're gonna start with the first chapter. A lot of you have seen differential equation from me or other things. All right. Yeah, it is a little bit, the picture is a little bit dark. I don't like it. All right. So I just showed you the textbook. So I'm gonna start with chapter one, and so we're gonna do. So the course site has been created on Canvas on Friday, this past Friday, and I did send you an announcement, couple announcement, where to find the syllabus, my textbook, and other related issues. Today, I will send you another announcement with the link to my YouTube channel so you can watch the recorded videos of the lecture. Okay? They will be called MTH 531, like video one, and so forth. All right? So we're going to take a look at, let's say we have a function x from an I to R. We have a function. Then the derivative of x at t star in I is denoted by xt star equal the lim as t approaches t star, x of t minus x of t star divided by t minus t star, provided the limit exists. Okay? So provided, can you read the board? Please reply.
It's a little dark, like you said earlier, but it's good.
A little bit dark? Okay, let's see if I turn the light. I mean, I don't know why it's dark, but if I turn the lights on, or from here, then you're gonna have reflection, right? Is this better? No?
It's good enough.
All right, thank you. All right, so x prime of t star is the instantaneous change of x at t star. Okay? So if x prime exists at every t in I, then we say x is differentiable on I. Okay? But it has to be, the derivative has to exist for every t in the interval I. Okay? Sometimes I may be the whole real number, r, which is minus infinity to infinity. That means the function x is differentiable everywhere. All right? So some notation. So for example, we may write x prime to be dx over dt. X second is d square x over dt squared. X third is d cube x over dt cube. And then once we start after 4, we took and so forth until xn, which is equal to dxn, or sorry, dn over dxn, dtn. Okay? So these, sometimes we use this notation. All right? Again, a general nth order differential equation, you're gonna see me write this a lot. Differential equation, or DE, correct? You may see me write this a lot. Is of the form, can be written as f of t x second to be xn equals 0. Okay? And let's call this is 1. All right? So we say phi of t is a solution on I if for every t in I we have f of t phi prime phi to power n is equal to 0. Okay? So what do we mean by that? For example, if I have a function, let's say x third of t plus 2 x prime of t x second plus x prime of t equal to t, then I can write this as f of t x prime, x second, and x third is equal to x third plus 2x x second plus x prime minus t is equal to 0. You see what I mean by that? So the function can be written like that. Okay? Any questions so far? I know a lot of you have seen ODE before and this and that, and so and so forth. All right. For example, the first order can be written as f of x, t, x, dx over dt equals 0, or x prime of t equal f of tx for some function f. All right. So for example, if I have x prime of t plus sine tx of t equal to t squared plus 1, then f of t x prime is x prime plus sine t x minus t squared minus 1 equals 0. And if I write x prime equal to minus sine tx of t plus t squared plus 1. So this is f of tx. So you have x prime equal f of tx. Okay? Any questions? All right. So if we have x prime equal f of t, then x of t equal the integral of f of t dt plus c, where c is some constant. For example, if I have x prime plus tx of t equals 0, then, no, actually, I want it to be x prime minus t equals 0, then I have x of t equal the integral of t dt, and that is t squared over 2 plus c. You know, well, you have to integrate. So this is it. So this has infinitely many solutions. Because of the C. For any C, you have a solution. All right? Okay. All right. So So let's say separation of variable. How it works. So let's say we have x prime of t equal to h of t g of x. And we're gonna specify x of t naught equal x naught for t bigger or equal to t naught. So now we have a differential equation and we specify an initial condition, specify initial time. That the value of the function is given at the initial time. So t naught is the initial time. And x of t naught equal x naught is the value of the solution at t naught. So this is the first point that the solution took care. So basically, we're gonna go x prime of t over gx equal to h of t. Okay? Integrate both sides. So I'm gonna have t0 to t x prime of s over gx of s ds equal to t naught to t h of s ds. Okay? All right? So if I do change of variable, u equal to x of s, so this equation is at, so I'm gonna do a change of variable with x of t naught equal x naught. So this is gonna be x naught to a t when s equal to t, u is x of t, and this is gonna be du over g of u, and that is equal to t naught to t h of s ds. I mean, we've all seen separation of variables, but I'm trying to show you why it works. Okay? So suppose we have dg over dx equal to 1 over g. So this equation is x naught to x of t dg over du equal to t naught to t h of s ds, and this one is g of u from x naught to x of t equal to t naught to t h of s ds. Okay? And then this is gx of t minus the gx of naught is t naught to t h of s ds. Okay? And then if you solve for the gx of t equal gx of naught plus t naught to t h of s ds, or x is g inverse of g of x naught, okay, plus t naught to t h of s ds. Okay. And so for some function where the G has has an inverse function. All right. And we will work on this. I am not giving you theoretical stuff yet. I'm just leading you through to where we are heading. All right. So as you see, the solution depends on T naught and X naught. So for emphasis, we may write X of T as X of T, T naught, X naught to emphasize the dependence of solution on the initial data. So that is emphasizing that the solution really depends on the initial data. Okay? We will be doing some examples and other things. So all right. So yeah, I'll leave this for a second for you, then I'll move it. I will assign some homework problems today, and you have to go log into Canvas and see when the due dates are for all the assignment. All right. Let's take existence of infinitely many solution in spite of given initial data. So let's do an example. Okay. And I'm going to take a look at x prime of t equal to 3.5 x to the power 1/3 x of t with x of 0 equals 0. All right. So basically, this is t naught. This is x naught. Okay. Why don't you go ahead for a second and solve it? This is separation of variables. Go ahead, take a few minutes and solve it yourself. Then I will be back with you and solve it with you. Don't forget the plants. You know. All right, so let me help you solve it. So we do separation of variables. So we have x prime over x to the 1/3 equal to 3.5. Integrate, okay? So we will have dx over x to the 1/3 equal to 3.5 dt, or ds if you like. Okay? All right. So I can start from here. I can apply my initial condition later. So this is x to the minus 1/3 dx equal to 3.5 t plus c. So this is x to the minus 1/3 plus 1 over minus 1/3 plus 1 equal to 3.5 t plus c. All right. So minus 1/3 plus 1 is 3/2, so it becomes 2/3. 2/3 x to the, again, minus 1 plus 3, 3.5 equal to 3.5 t plus c, multiply by 3.5, 2/3, multiply by 3.5. So you get x. So let's see.
It should be x to the 2/3, not 3/2.
Oh my God, I know. I am adding exponent, x to the minus 1/3 plus 1 over minus 1/3 plus 1. What did you say?
On the right-hand side, once you integrate, it should be x to the 2/3 instead of the 3/2.
Oh, here, right?
That's correct, but when you move over to the right, you have x to the 3 to the power, it's x to the 3 over 2. It should be x to the 2 over 3.
I'm doing like this.
Correct.
Minus 2/3. Sorry, yeah. Oh, okay.
There you go. There you go.
2/3. And so what else do we have? That is, and then if you solve for x, why am I not getting?
Your coefficient needs to change on the x now. It should be 3 over 2 instead of 2 over 3. There you go.
So let's see. Minus, this is 2/3. So this is over 2/3. So this should be 3.5, right? All right, if I multiply by 2/3, so I'll get x to the 2/3 equal t plus another k. correct? And then if I apply x of 0 equals 0, then I'm gonna get 0 is 0 plus k, so k is 0. So that means x is t, all right, to the 3.5. All right. Okay. So if you look at the solution, x of t, this is one solution for 0 for t less or equal to 0, and t to power 3.5 for t is bigger than 0. So this is one solution, and if you look at the picture, t less or equal to 0, you get this solution, and then for t bigger or equal to 0, you get this solution here. All right. So, and if you take, since this is symmetric, you can continue. So, and then if you start here, this is again another solution, again another solution. This is called the translation. Okay. And this is t minus t1. So another solution is x of t is t minus t1 to the power 3.5 for t bigger or equal to t1. So for any one, for any t1, that is also a solution, is a solution. So this is by translation. Okay. So again, if x is a solution, then minus x is a solution. So you will get those. Okay. So this equation has infinitely many solutions. All right. And if you notice, why is this? Look at our equation was x prime as x to the 3.5. Is that what it, or 2/3? 1/3 was 3.5 x to the 1/3 with x of 0 equals 0. So when we did the separation of variable, we wrote x prime over x to the 1/3 equal to 3.5, and you see at 0 this is undefined. At time t equals 0, you are dividing by 0. So that is not, this is the problem when x equal to 0. Okay. So that caused the solution to break down at every translation point. So this is something that we are going to address in this course. Why are we having multiple solutions, not only one solution, even though we have an initial condition? And another breakdown is, so if I have x prime equal x cubed, let's take another example, x prime of t equal x cubed of t with x of t naught equal x naught. So go ahead and solve this equation for a second. And find your constant c. Go ahead. the problem read x prime equal x to power 3 of t with initial condition xt naught equal x naught. All right, so again, it's x prime over x cubed equal 1, or dx over x cubed equal dt. So this is x minus 3 dx equal to t plus k. And that is x minus 2 over minus 2 equal t plus k. All right. Okay. All right, so if you multiply by minus 2 equal minus 2t plus c, if I multiply by minus 2. Okay, now I change the c to minus 2k. So this is 1 over x squared. Okay, that's fine. What is our c? So x0 minus 2 equal minus 2t0 plus c. So c is x0 minus 2 plus 2t naught. And from here, we got 1 over x squared equal minus 2t plus c. And then 1 over minus 2t plus c equal to x squared. X is a plus or minus of 1 over c, or minus 2t plus c plus 2t naught plus x0 minus 2. And that is plus or minus 1 over the square root of minus 2t plus 2t naught plus x naught minus 2. All right? So here, even though we have a unique solution, we only have one solution, but the solution breaks down at, we see that the solution breaks down at minus 2t plus 2t naught plus x0 minus 2 equals 0, or 2t equal to 2t naught plus x0 minus 2, or t is 2t naught plus x0 minus 2 over 2. So the solution will break down at this value here. So this is another example where the solution does not exist at a certain time, even though the solution is unique, but as soon as it approaches this value, the solution will break down. So these are two different examples. One has infinitely many solutions, and one has the solution will break down. Okay? Any questions? Now there is a lot of some examples that I'm not gonna go over. Other things in this section, like the escape velocity and other things. So I'm gonna ask you to read it. Okay. So I'm gonna skip a lot of this stuff. And then go to variation of parameters formula, section 1.5. Any questions so far? Any questions? Okay, so I'm gonna go to so this is section 1.5. Variation of parameters formula. Okay. So we're gonna consider the nonlinear first order initial value problem. Initial value problem because you have initial condition. That's right, because you have an initial condition. So our equation is going to be x prime of t plus, let me get the formula correct here, plus AT, equal to ATXT plus a g of t x of t with x of t naught equal x naught, where A is continuous from 0 infinity to R is continuous, and similarly the G is a function from 0 infinity across R into R is also continuous in both T and X. Okay, sometimes we use this notation. A belong to C, 0 infinity to R, to indicate that A is a function with the domain 0 infinity into R that is continuous. Let me go say bye to my daughter and her children. They're leaving to Tennessee. I'll be back with you in a few seconds. All right. So, and again, I can write G as G belong to C of 0 infinity cross R, okay, cross R, like that. So that means G is continuous from 0 infinity cross R into R. Okay, so this is the same notation here. All right. Okay. So the integrating factor, let me see what I called the equation of 1.51. Let's call this is 1.5.1 is exponential to minus, okay, as ds from t naught to t. Okay. Okay, in the book I wrote u, so let me stick with u in the book. All right. So that is the integrating factor. Remember, x prime is equal. If it was a plus, it will be a plus here, correct? Because 1.51 can take x prime minus atxt equal equal to. So I wrote it like that. So let's leave with it for now. Okay. So we multiply 1.5.1 by, so let's call this is a mu equal to, this is the integrating factor, is mu equal to e to the minus t naught of t naught. So if I write it, it's gonna be mu t x prime of t equal to at mu t plus mu t g of t x of t. All right. So we're gonna notice that d of, we're gonna notice that mu t x prime of t minus mu t at is d of dt of mu t times x of t. Okay, so if you bring this over here, then this is what it's equal to like. Okay, so this equation, yeah, I did not call it. Let's call it a star. Let's call this as a star. Are you with me? All right, I'm gonna flip the board, so I'll give you a few seconds to look at it before I flip. All right, let me flip the board. Then the star is equivalent to d of dt mu t xt equal to mu t gt x of t. Okay? All right. So now integrate both sides from t naught to t. So what we're gonna get is t naught to t d of ds mu s x of s ds equal t naught to t, sorry, mu s gs x of s ds. Now, that one, I don't know what it is, so I'm gonna leave it alone. But this, I can integrate. This one is mu s x of s from s equal t naught to t equal to the right-hand side mu s gs of x of s ds. Okay? Let you catch up. All right, so this is mu t x of t minus mu t naught x t naught equal to t naught to t mu s gs x of s ds. Remember what the mu t is. The mu t is e to the minus t naught to t au du. So mu of t naught is 1 because that is e to the minus t naught to t naught au du, that is e to the minus 0, that is 1. Okay? So we're gonna have x of t equal to, this is 1 So let's take it over there. And x t naught equal x naught is x naught plus t naught to t mu s gs x of s ds. And this is 1 over mu t. Okay? It's 1 over mu t. Now, what is that? So that is, a mu t is that, so it's going to be e to the t naught to t au du times x naught plus t naught plus e t naught to t au du times t naught to t and mu of s times the gds. I'm going to do some work here. Let's take a look at e to the t naught to t au du times t naught to t mu s gs xs ds. So that is equal to t naught to t e to the t naught to t au du times this mu s, that is e to the minus t naught. Okay, remember what the mu t is. Mu t is this one. So if you replace t with s, because you got a mu s, so that will be e to the minus the integral t naught to s au du times the g of s x of s ds. Okay? Now remember, u is between t naught and t, and s is between t naught and t. So u is between t naught and s. So if I look at this one, so if I look at, this is t naught, this is s, this is u. Okay? All right. And that is t. Okay. So what do I have? I have from here, u from t naught to t, I have all the way from here to here, minus. So if I want me, I can write another line for you. This says e to the t naught to t au du minus t naught to s au du times g of s x of s ds. You see, you can add the exponent. So now you go from t naught to t minus t naught to s. So you get from s to t. Okay? So you get s to t au du. All right? So this here is equal to t naught to t e to the s to t au du g of s x of s ds. All right, so now let's do it here. So finally, the solution is x of t equal to, you know, this one here is going to be x naught e to the t naught to t au du plus this term t naught to t e to the s to t au du gs x of s ds. There you go. So this is called the variation of parameters formula. Okay? All right? And the name of this equation formula is, let's see, the final formula is 1.52. So this is 1.5.2. Okay? Now, if a of t equal a is constant, there's no t, then 1.52 reduces to x of t equal x naught e to the t minus s, t minus t naught, sorry, x0. This will be a constant, that will be t minus t naught, you integrate it, plus t naught to t, and that will be a function e to the t minus s g of s x of s ds. You see that? This is a simple form if a is constant. So let's call this is 1.53. Okay. Then if at equal a is constant and g equal to g of t, a function of t only, then from 1.53 we have x of t equal to x naught e to the t minus t naught plus t naught to t e to the t minus s g of s ds. Okay? So these are much easier formulas to use. So let's take a look at x prime of t minus x of t minus t equals 0. So if I look at this formula, this is x prime of t equal x of t plus t. So at is 1 and g of t is t. So I can apply, let's say this is 1.54. So we apply 1.54. So we got x of t. Okay, let's say I have x of 0 equal 4. So it's gonna be 4 e to the t plus 0 to t e to the t minus s times s ds. Okay? All right, can you integrate this? So if you want to integrate this, so we got x of t equal 4 e to the t. Now the integration is done with respect to s, so I can take e to the t out. 0 to t of s e to the minus s ds. Now I need to integrate s e to the minus s. Go ahead, integration by parts. Just take a few minutes and you do it. You need to refresh your memories a little bit. All right, if I let u equal to s and dv is e minus s ds, then du is ds and v is minus e to the minus s. So s e to the minus s ds from t0 to t is u v is minus s e to the minus s from this is 0, sorry, 0 to t plus, remember, it's uv minus v du, 0 to t of e to the minus s ds. So this is minus s e to the minus s minus e to the minus s from 0 to t, and that is minus t e to the minus t minus e to the minus t minus, if you put 0 in, you're gonna get 0 minus 1. Because if you put here, okay, plus 1. All right, so this is minus t e to the minus t minus e to the minus t minus 1. So your solution, x of t is 4 e to the t, oh, sorry, 4 e to the t plus e to the t. Now I have this is minus t e to the minus t minus e to the minus t minus 1. Now multiply by e to the t. This is 4 e to the t minus t minus 1 minus e to the t. And that is 3 e to the t minus t minus 1. Okay? Let's see. My initial condition is not working out. What do you think? So I got 4 e to the t I have a sign mistake somewhere. Let's see. Let's try to recover it. So we did integrate s e to the minus f, that u equal s dv is e to the minus s ds, du and v is minus e to the minus s. So this is equal to uv minus v du plus e to the minus s ds. And that is minus s e to the minus s 0 to t minus e to the minus s 0 to t. And that is, let's see. If I put t in, I get minus t, e to the minus t, minus e to the minus t, minus. If I put 0, I'm gonna get, oh, I already included the minus here. Oh, so this should be minus 1. This should be plus 1. Okay, there. There. Okay. So that is your solution. Okay. All right. Now you could do, you say, oh, Dr. Raful, I mean, we know how to do this one easily. Yes, you do. But this is the whole formula, where the formula came from. If you look at this problem, x prime of t minus x of t equal to t. So the integrating factor is e to the t. So this is d of dt x e to the t equal t e to the t. Okay? Oh no, the integrating factor is e to the minus t. Minus, right? Then integrate, then you will get 0 to t x of s e to the minus s ds equals 0 to t s e to the minus s ds. And then you'll get, this is d of ds. And then you will get the same answer. Okay? And then you can apply both, you can apply the formula whatsoever. All right. Now, this textbook is unlike others you studied, like especially the last semesters. The exercises are at the end of the chapter, not at the end of each section. So that makes it more challenging, because after you learn different sections, then the homework doesn't tell you which section to use or to refer to do the homework problems. It does make it a bit challenging, but it's really not that bad. So let me go on for another 10 minutes, then I'll hush. So now, I'm jumping for chapter 1. I'm gonna look at section 1.6 now. Special ODEs. ODEs. That means ordinary differential equation. Okay. So let's say we have x second equal f of t x prime. How do we solve this equation? Somebody talking? No, me. Okay. So the best thing to do is let x prime equal u, then you have u prime equal f of t. If I have f of okay, so let me take a look at a special case. Okay, and let me take a look at x second equal to f of tx prime, then you let u equal x prime, and then u prime is f of tu. And then hopefully this is the first order, you can solve it. All right. Okay, so let's take a look at tx second plus, so this is an example, 2x prime plus t equal to 1. And t is bigger than 0. All right, let's say we have this differential equation, and that is a little bit complicated. So this is of the form of this one. This is of this form. X prime, okay? Because I can write, so I'm gonna let u equal x prime. Then this is gonna be tu prime plus 2u equal 1 minus t. Divide by t, or u prime plus 2 over tu equal 1 over t minus 1. So basically, as you can see, this is of the form x prime plus at x of t minus g of t equals 0. So here, at is minus 2 over t, and g is 1 over t minus 1. Okay? So you can, what is the integrating factor for this equation? The integrating factor is e to the 2 over t dt. That is e times 2 ln of t. That is e to the ln of t squared, and that is t squared. I'm not going to use the variation of parameters. I can do it right away. So this is d of dt of t squared u of t equal to t squared times 1 over t minus 1. Okay? So, and that is t minus t squared. So integrate, you will get t squared u of t equal to t squared over 2 minus t cubed over 3 plus c. Okay? So we have to integrate, and this is what you get. Now, divide by t squared. Okay? Divide by t squared, you get ut equal to 1/2 minus t over 3 plus ct minus 2. Remember, x prime is used, so x prime of t is 1/2 minus t over 3 plus ct minus 2 integrate. So you get x of t equal t over 2 minus t squared over 6 plus c over t or minus plus some number k. And there you go. You got your solution. Okay? Minus C1 over T plus T over 2 minus T squared over 6 plus C2. All right? Okay. So do you have any questions? Is there any complaint about the video I should change? Please speak honestly before so I can work on it today and try to improve the presentation, the board and the colors and everything. Is there anything you want to say? Oh, somebody want to meet the dog. Where is Lily, honey? Come on, Lily. Let's go see us. Yeah. Wait. Down. Wait. Okay. Well, here is Lily. Lily, say hi to everybody. Say hi. There we go. You can go now. All right. She was lazy on the couch. So now you saw Lily. She get introduced every summer. Anything else? Again, expect an announcement from me giving you the YouTube link to where all the videos will be stored, shared with you. All right. Thank you very much. And I will see you tomorrow. Okay, there is chat, 4 things. Where is the dog? I'm good. I can read. All right. We'll see you tomorrow. I'm going to stop recording. Okay.